Okay, so for today's lesson, we're focusing more on that idea of slope. So we kind of talked about slope last semester. We didn't talk about how to find slope, but we did talk about the different types of slope. And remember, there are 4 types of slope. So I'm going to go ahead and draw 4 coordinate grids here and then draw the lines out. And you're going to remind me what type of slope that was. So if I draw a line right here on my first coordinate grid, what kind of slope, what type of slope was that? Tyler? Positive. This is a positive slope. Okay, it has when you're reading it from left to right, it's increasing in its position. Okay, then we have this one. Okay, what kind of slope was this one, Isaac? Negative. Okay, so when reading it from left to right, it kind of went downward in its positions. Okay. What about this third one? What type of slope was this third one? Jaden?
Zero.
Zero slope. Okay, a flat horizontal line, we called that zero slope. And then our last one, when it was a vertical line, what kind of slope was that vertical line? Ariana? Undefined. Okay, so remember we had that slope dude and he was saying puff, puff, positive as he's going up the hill. It was a nice negative as he was going down the hill. When he got to the flat surface, he said it was zero fun. And then when he got to the vertical drop, he said it was a curse word, undefined. If you have your computers opened, if you could please go ahead and close them, that would be great. Thank you. All right, so talking about our coordinates for here. So we want to identify what the coordinates are going to be for specific points. So we have point A and point B are running along a line that passes through the origin. So remember, we call this a proportional graph if it's a straight line and it goes directly through the origin. And so we are wanting to go ahead and identify some specific coordinates of each of the following points and then what the slope would be for those points. So when we're looking at slope, well, first things first, I want to make sure you guys understand that when we're talking about a coordinate, we're talking about a x value and a y value. Okay, your x value is the part that goes from left and right. Your y value is the portion that runs up and down. Okay, so that's what we're talking about when we're talking about a coordinate. And we're saying it goes through the origin, so that means that it happens to be at 0, 0 in this position. Okay, now we want to know what are the following points going to be based off of how we're moving in our origin. So we're utilizing slope to help us with that. So slope, in case you were not aware, slope is a fraction value. It might be proper, it might be improper. We never write it as a mixed number. Okay, it's always just a pure fraction. Where the top number, we call it our rise. So that means how far up and down we move. If we are moving up, we're moving in a positive direction. If we move down, we're moving in a negative direction. And then on the bottom of our fraction, we call that the run. So that is moving us from left and right positions. If we're moving to the left, that would be a negative position. If we move towards the right, we're moving in a positive direction. Okay? So up is positive, down is negative, left is negative, right is positive. And rise and run represent our up and downs and our left and rights. Okay, so when we're looking here, if I'm trying to identify what my slope is going to be in this situation, I want to identify those rise and run values. So for my rise, it's again how far up and down I'm going, and for my run, it's how far left and right I'm going. So if I'm taking a look here, I have 2 different rise values. I have a rise of 3. I also happen to have a rise of 6. So I have 2 very different rise values, a rise of 3 and a rise of 6. I also have 2 different run values. When my rise was 3, my run was 4. When my rise was 6, my run was 8. So we have a 6 and an 8. Now, if I were to simplify these, I don't know why I wrote a 6 here. That's my bad. That should be a 4. If I were to simplify them, they both simplify to the exact same value. They both simplify to a 3/4. Okay, so that would be my slope in this situation. And that slope is basically direction. It's telling us that every time we move up 3 positions and move to the right 4 positions, it's taking us to the next point on a line. Okay, and it does not matter which points you happen to pick. So in this situation, if I'm moving to the right 4 and up 3, what point will point A be at? If I'm moving to the right 4 and up 3. If I'm starting at, so I'm starting at 0, 0, and I'm going to move to the right 4 and up 3. Who can tell me 4, the value of 4, does that affect my x or my y? My x, right? This affects my x. So that means I'm going to take x and I'm going to add 4 to it. So here's where my x value was. I'm going to add 4 to it. And then the y is what is affected by that vertical. So that 3 is going to affect my y. So that means I'm taking my y value and moving up 3. So I'm taking 0 and adding 3. And that's going to take me to my next point, which is 4, 3. So from this point, point A is at 4, 3. I want you guys to figure out what is the value of point B. What are the coordinates for point B using that same method? All right, who can tell me what they got for point B? What is that going to be? Madison? 12, 9. Very good. Okay, because again, what we're doing from here is we are now adding 8. But we're not just taking the old value. We're starting at 4, 3, and we're going to add 8. So we're going to do 4 plus the 8. So I'm adding 8 to this position, and that's going to take me to a 12 for my x value. And then we're doing the same thing for the y. Starting at this value of y, which was a 3, we're going to take 3 and add the 6 to it. So we're adding 6 with the 3, and that's going to take us to the value 9. So our y coordinate is a 9. Okay, so we have now the points 12, 9. So again, your slope is just basically a direction. Now, it does not matter what 2 points you pick. Notice that I'm creating different types of triangles. All these triangles are proportional to each other. That means that they have the exact same slope. So no matter where you pick a point on your line, no matter what triangle that you form for your rise and run, they are going to have the exact same slope. Okay, so let's take a look now at this next problem. We're finding a point on the line. We want to know what is the slope of line J. So we want to know the slope of it. And then which of the following points are going to be along line J? We want to know, is 20, 15 going to be on there? Is 90, 68 going to be on there? So first things first, let's go ahead and identify what the slope is going to be of line J. So that's this line. And we can identify our slope by finding our rise and our run. So let's take a look at what the run is. So we already have a little triangle that's been positioned here for us. Our run is how much? What's our run going to be, guys? 4. Okay, so our run is going to be 4. And then we have our rise. What's our rise going to be? 3. Our rise is a value of 3. Okay, so when we're creating our slope, again, our slope is going to be the rise over the run. So our rise was a 3, and then our run was a 4. So we have, again, another slope of 3 over 4. Okay, so we want to know, could these be potential points that are on our actual graph? Because we don't see these points. It's not like I can go, oh, I can go over 20 and up 15 and see if that actually works. But what we can do is we can look to see if the change that's occurring from one point to the next is going to result in the same simplified slope, okay, the same simplified rise and run. So we're going from our point that we have located right here, which is 4, 3. right? If we moved over 4 and up 3, point B happens to be a 4, 3. So what I can do is I can check to see, in order to go from 4, 3 to 20, 15, how much did I have to increase my x by? By what? To go from 4 to 20? By 5? Not multiplying. Remember, we're adding. Rise and run gets added from one point to the next. So 16. We're increasing that by 16. What about to go from 3 to 15? We increased by 12, right? So there's my rise and my run. So my run would be a 16. My rise would be a 12. So now we're going to create our slope. So we put our rise on top of 12. We put our run on the bottom of 16. And I want to know, is it going to simplify to 3 over 4? So 12 over 16, will that simplify to 3/4? What are they both divisible by? 12 and 16. 4. Okay, they're both divisible by 4. 12 divided by 4 is going to give us a 3. 16 divided by 4 is going to give us a 4. So it's the same slope. So is it on the same line? Yes. Okay, so 20, 15 is going to be on this line. Let's do the same thing for 90, 68. So I can actually start with 20, 15 because I know that that's a point on there. I know 20, 15 is a point that's on my graph. So I'm going to actually work from there. If I've got the point 20, 15, I want to know, actually I'm going to do it down here so I have more room. If I have the point 20, 15, and I want to get to the point, we'll do I have a red? I don't have my red anymore. Okay, we'll just do black. And I want to get to the point 90, 68. I need to know what is my run and what is my rise. So who can tell me what the run would be to go from 20 to 70? What are we increasing by to go from 20 to 70? Oliver, what are we increasing by to go from 20 to 70? Huh? I mean 20 to 90. 70. Oy, thank you. Mason, what are we increasing our rise by to go from 15 to 68? 53. Okay, so I want to know, is this rise over run going to simplify to 3 over 4? So we're going to take our rise of 53 and we're going to put it over our run of 70. And does 53 over 70 simplify to 3/4? Isaiah? No. Okay, it's just going to stay 53 over 70. That's as simplified as it gets. So no, this is not going to be a point on the graph. This one is. This one is not. So you got a point, you got one that's not a point. All right, flip it on over to the back. I want you guys to go ahead and do those two problems on your own. You're going to do these two problems on your own. You're going to identify what the slope is based off of what's drawn here. I want to know, does the point 20, 40 lie on this line? And then the point x 20 lies on the line. So I'm telling you there's a value where x is a number and then y is 20. What is the value of x going to be when y is equal to 20 if it has to fall on this line? And then for the second one, you're going to determine what the slope is, and then you're going to determine whether the point 2131 is going to lie on that line. For today. Okay, for here, when we're identifying the slope, if we're taking a look here, our rise happens to be the 3. Our run happens to be 6. So when we are putting that in for our slope, and slope is going to be in a fraction form where you have the rise over the run. So our rise of 3 would be on the top, our run of 6 would be on the bottom. And then, of course, you always must simplify. So 3 over 6 can simplify to 1 over 2. So there's your slope, 1/2. We want to know, does the point 20, 40 lie on the line? So all we're going to do is pick one of these points. It doesn't matter which point you pick. You just pick one of them. So I'm going to go ahead and pick this point, the 10, 9. So I'm starting off at 10, 9. And then I'm going to check to see what the slope would be if I'm going from 10, 9 to 20, 40. Okay, if I'm going from 10, 9 to 20, 40, my run in this case would be to add 10. So there's my run. My rise in this case would be adding 31. So I'd put 31 on top. Rise over run. Remember, it's always rise over 1. Well, 31 over 10 just stays 31 over 10, which is not equal to 1/2. Therefore, this is not on the same line. They are not on the same line because they are not the same slope. Has to be the same slope in order for it to be on the same line. Okay, now we want to know the point x 20 is going to be on that line. I know x comma 20 is going to be on the line, so I want to know the value of x. So again, I'm going to start off with that point that I had here, that 10, 9, and I know that I'm going to have to do a value that's going to get me to x comma 20. So I'm going from 9 to 20, which means I'm going to have a rise of 11. I'm going to have a rise of 11. So if I know my rise is going to be 11, I need to know what my run is going to be. What?
Mr. Kirk said your cleaners are absolutely nobody's paid, so you need to send some cleaners.
Okay, thank you. Jaden and Madison, can you guys go and clean, please? Thank you. All right, so I have a rise of 11. I need to know what is the run going to be so that the slope is the same thing as 1 over 2. Okay, so you can easily do a quick cross product to be able to work that out. If I do x times 1 is just going to come out to x. And then if I do 11 times 2 is 22. So I get x is going to be equal to 22. Everybody follow that so far? Okay, I know what my rise is going to be. I have to use that rise to be able to find what the run has to be in order for the slope to be 1 over 2. So the run is going to be 22. So what is 10 plus 22 going to give us? What's 10 plus 22? 32. So x is going to have to equal 32 in order for it to be on this graph, on the line. This right here, what I just did, guys, this part, you're going to be doing in IXL, doing this exact same thing. So you need to make sure you understand what I just did here, because this is your skill today on IXL, is given a graph and the slope and a point with a missing coordinate, what is the missing coordinate going to be? So let me go over again. I have a point, 10, 9. I have a slope of 1 over 2. I need to know what is the x coordinate going to be if the y coordinate is 20 and they're on the same line. So the first thing I do is I find either whatever the rise was or whatever the run was to get me from the point I know to the point I want to go to. Sometimes your x is missing, sometimes your y might be missing. So in this case, our y was given to us, so we knew the rise was going to be from 9 to 20. It was going to be a rise of 11. So then you can set up a proportion. Rise over run equals the slope rise over run that you know. And then you can do your cross product to solve for the missing run in this case. Once you know your missing run, you combine that with your old coordinate to get your new coordinate. Okay? All right, let's take a look at the last problem. For our last problem, we're going from 3, 7 to 6, 11. I want to determine the slope. So the first thing I'm going to do is determine the rise and the run. So you're creating a right triangle. Remember, you can create all sorts of different triangles on the same line and they all have the same slope. So I can create a triangle here where I'm highlighting my rise in pink and my run in blue. The rise, to go from this point up, how much did I increase by? To go from here up, what was that an increase of? Vincent? 4. Okay, what was the run going to be here? What was my run increasing when I'm going from this corner to my last point? What is the run in this case? Mackenzie? 3. Okay, so here's my rise, here is my run. So again, we put rise on top, which means 4 is going to go on top. We put the run on the bottom, so the 3 is going to go on the bottom. So we have a slope of 4/3. You do not convert that into a mixed number. You leave it as 4/3 because it has to be a rise over a run. There is no mixed number, no whole number part. Okay, so we want to know if the point 2131 is going to lie on the line. Okay, so pick any one of these points. It doesn't matter which point you picked. I'm going to go ahead and pick this one, the 611. And then for 611, I'm now going to this new point, 2131. I want to know, is the rise over run going to be the same as 4/3? Okay, so for my rise, I'm going from 11 to 31, so I increased by 20 for my rise. So my rise was 20. For the run, I went from 6 to 21. I increased by 15 for my run. So my run was a 15. So we now have 20 over 15. 20 over 15, they both happen to be divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. I got 4/3. That is the same slope. So then yes, this is going to be a point on the graph. 2131 is a point on that graph. All right, what I need you guys to do is you're going to go ahead and go into Google Classroom. You have a single IXL skill for today. Go ahead and get that completed. When you finish the IXL skill, you may then work on any missing DLD work if you have it. And I mean any work. If you've got missing DLD work for another class, you can work on that as well. But you must do my IXL skill first before you get onto DLD work. If you do not have any missing DLD work, you're going to get onto iReady Math, My Pathway iReady Math.